Bridges are one of the finest examples of human ingenuity. The first ever bridge is said to have been built as early as 1300 BCE in ancient Greece. The 22-foot-long Archedico Bridge was made using stone blocks, possibly to allow chariots to pass over a narrow stream. Back then, the Archedico was one of the only arc bridges to have ever existed. And as a testament to Grecian engineering skills, it has somehow survived thousands of years and is still being used by locals and Argolis to this day. In 2023, however, Archedico has plenty of other bridges to keep it company. Some, such as the Golden Gate Bridge, are renowned for their iconic design. Others, such as the world's tallest bridge, the Izai Suspension Bridge, are regarded as some of the greatest examples of human engineering. Despite the thousands of years that separate their construction, there is a lot more in common between the Archedico, the Golden Gate Bridge, and the Izai Suspension Bridge than you may think. They have the same purpose, similar basic structure, and they were all extremely challenging to create. In this video, we're going to examine the last of these threads. Despite the latest advancements, what makes mega bridges so hard to build? Let's take a closer look. Mega bridges, or all other mega projects for that matter, are by definition complicated to build. They cost over $1 billion to make, and have a major impact on the community around them. For the purposes of this video, we won't consider a simple beam bridge over a stream a mega bridge, no matter how well known it is among locals and tourists. Instead, we will analyze the difficulties of building massive mega projects, such as Lisbon's Vasco da Gama Bridge or the Port Mann Bridge in Vancouver. Building a mega bridge is a risky and expensive project. It's also one that requires a deep level of research and understanding of the environment where the bridge will go. Building the world's longest bridge, which is currently the Danyang Kunshan Grand Bridge in China that stretches over 100 miles, follows a similar process as building a simple bridge across a tiny stretch of river. The first step is site inspection and planning. In this stage, engineers will test the soil and other elements near the site to ensure their structure will stand tall for years. With the help of modern technology, this process is computerized and allows engineers to understand how several variables will impact the integrity of the bridge. The next step is setting the foundation. Once the ground is broken, builders must install pillars. These will bear the weight of the bridge. These foundation blocks are typically built with concrete. The engineers will then install support systems, which enable the bridge to withstand force from either direction. These support structures include beams, bearings, abutments, and pillars or piers that come together to form the substructure. Everything that goes on top of the bridge and eventually holds the weight of the cars or trains that pass over them is collectively called the superstructure. It usually includes arches, suspension cables, or steel and concrete girders. Assembling the superstructure is one of the trickiest parts of building a mega bridge, as it must be resistant to various forces, such as gravity or wind. The final stage is inspection, during which engineers assess, with the help of cranes and other heavy equipment, where the bridge is actually structurally sound. While these are the 5 stages most engineers will follow, things get more complicated depending on the bridge site. Bridges built in water, for instance, may require engineers to create makeshift dams or platforms for the concrete towers to stand on. It may also require constructors to dig deep under the surface to achieve stability, since riverbeds usually have unstable soil. Similarly, bridges built over tall canyons face their own set of unique challenges. Now that we've briefly examined what goes into the construction, we are more equipped to understand where things can go wrong. The first issue comes with the site itself. Some areas are, as you'd imagine, more challenging than others. When building a bridge in Alaska, Siberia, or anywhere in the Arctic, for instance, engineers must deal with the presence of permafrost. If that wasn't hard enough, melting permafrost is equally problematic, as thawing ground is unstable. At the same time, some mega bridges, such as the Golden Gate Bridge, are built in seismic zones. making it earthquake-prone and actively widening the gap engineers are trying to bridge every year. Some megabridges must be built in extreme wind tunnels, others on sand or other porous soil, and some in deep water. Each case presents a unique challenge. There's often some overlap between these problems as well. Engineers who built the Rio and Torrio Bridge in Greece's Corinth, for example, didn't just have to build a bridge in a seismic zone, but also deal with the fact that the land they were trying to connect was drifting further apart every year. Moreover, the bed of the Gulf of Corinth is made of highly porous sand that goes over 1,500 feet deep. Building bridges in mountainous regions also comes with its own set of issues. Digging deep in such tricky conditions can disturb the soil, causing more landslides, for instance, or disrupting water supplies. Clearly, civil engineers have a lot going on during the planning and design stage, but that's not where the trouble ends. Getting access to high-quality equipment, such as floating docks when building in the sea or the mountains, can be expensive. With regard to costs too, there are many restrictions. Most construction projects, as we already know, tend to exceed budgets and run into several scheduling problems, largely because of the challenges in the planning and design phase. And once all of that has been considered, there is always the fear that local communities may not find the bridge aesthetically pleasing. The Tappan Zee Bridge in New York, for instance, has for years been hated by the locals, who call it the Big Ugly. But at the end of the day, understanding more about the dozens of factors that make building megabridges so difficult only makes some of the completed projects look even more impressive. So, the next time you drive over a bridge in the water, spare a second to think about how a simple stone structure from ancient Greece has led to humans pulling off some of the most ingenious construction projects in the world.